Hey guys, in this video we'll have a look at MapBox and we'll see why it might be a great idea to use it in your next project. Not only that, we'll be building a complete Flutter application together where we'll be using MapBox, we'll be using its Maps SDK, the navigation SDK, and also create a route between a source and a destination. I'm really excited to get started. Let us begin by understanding what exactly MapBox is. So MapBox is a modern and flexible map service which you can easily integrate into your web and mobile applications. If we have a look at the MapBox website, we see that they provide us with a lot of features such as the navigation SDK. We have the MapBox Studio, which is my personal favorite. You can do a lot of modifications like changing camera angles, 3D features, colors, fonts. You can completely customize how your maps look and behave. Then you have the Maps SDK for integration. You have the search APIs, the Vision SDK, data and Atlas. So the question which arises is why should we choose Mapbox and why should we not choose Google Maps platform? There is no doubt that Google Maps offers one of the best services in the industry, but there is only one field where Google Maps lags behind, and that is pricing. In fact, Mapbox came into limelight when Google started to make a business out of its Map API. If we have a look at the pricing of Mapbox and compare that with Google Maps, we see that Mapbox has a much more generous free tier. Let's say we look at the Directions API here, we have 100,000 monthly free requests. But if we go to the Directions API inside Google Maps, we have to pay $5 per every 1,000 requests that we make. And yes, Google does offer you $200 of free credit per month after you set up your billing account. But then that is just 40,000 free requests per month for Directions API, provided Directions API is the only thing you're using, which I doubt will be the case. So that is pretty clear that Mapbox offers a better pricing model as compared to Google Maps, and that is why Mapbox started gaining a lot of customers. Let's say we have Yahoo, we have CNN, we have New York Times, we have some names like Adobe and IBM. Perhaps the biggest two names that Mapbox added to its list is actually Snap International Corporation and Facebook, both of which also use Mapbox for their services. So two things are clear now. Mapbox has a lot of features and it has an amazing pricing model. So if you're a startup who is just entering the market, you are, let's say, a developer who is making the next big product, you are a student community who is trying to build something for college, or pretty much everyone who is trying to avoid huge bills, Mapbox is the solution for you. Now that being said, I think it's time for us to get started with the coding. You'll find a link to a GitHub repository in the description and clone the repository, open your favorite IDE, VS Code, Android Studio, whatever you want to, and let's get started. So this is the GitHub repository I was talking about. Based on the time of you viewing the video, the repository might look a little different because I am continuously updating it. But yeah, the folder structure is going to stay the same. You'll have two folders here. One is completed code and one is starter code. So the starter code is the one which you should be using. You should clone the repository and then you should open this particular folder. Now, before we can actually start writing code, we'll have to run the starter code. So for that, we'll need to do some initialization in the code, and those initialization will be done in basically 5 steps. So the first step that we have to take care of is actually creating our own account in Mapbox. You can sign up for a new account, and when you create a new account, you will be getting a public token like this here, and you can also have an option to create a token. So Mapbox works based on two tokens. One is a public token and one is a secret token. So a secret token that you can create, so when you click on this, you can actually choose any particular XYZ name. But the one thing you should make sure is actually selecting the downloads read option. So this must be checked, and then you can add your own URL restrictions if you are using it for the web, so that you want to prevent malicious activities. And then finally you can click on create a token. So I have already created my token. I won't be creating a new token, but you can follow these steps along. So once you have created those tokens, it's time for you to use them in your code. So I have actually cloned and opened the starter code here, and I also have my simulator running, which we'll be using for development throughout. And I'm running Android Studio right now. You might be using VS Code. That's completely all right. You can follow along. So the first thing that we have to do is we have to set it up for the iOS. For iOS, we need to take care of two things. That is, we have the info.property list here, where you have your public access token. So your public access token should be replaced by the public access token on your Mapbox account. And the other thing that we have to take care of is actually using your secret access token. So for iOS, that works in the following way. If I open my terminal and I look for this file in my home page, that is a .netrc file. This stores some of the passwords and other stuff that your iOS system uses to download stuff. So in our case, if you remember, we had selected download read access option in the secret access token. So in the .netrc file, we have to basically add a few lines that will allow the system to download the Mapbox API onto your device. That works in the following way. I am not opening mine because that already has the secret token, but you have to write these three lines basically: machine api.mapbox.com, and the login should be Mapbox. Remember, this should not be your user ID or anything else. It should be Mapbox only, and the password should be the secret token that you have created. So if you add these three lines in your .netrc file, it should be fine, and that will be all you have to do for iOS. For Android, what you have to do is you have to save your secret token in the gradle.properties file. So you have your secret token written here. You'll just have to replace this with whatever secret token you get. And similarly, you also have your public access token inside your app source main resource values and strings.xml. So in strings.xml, you have this thing mentioned as well. So you have to put your public access token here. Now remember one thing that we have to take care of is that your public access token looks like pk dot some strings xyz something, and your secret access token looks like sk and dot something. So these represent the public key and the secret key respectively. So that will help you distinguish between those keys and keep a track of what you are putting where. And another simple thing which you could do is to just use the search in the entire project. You can look for public access. You can also look for, let's say, secret token. So you can replace this here. So that concludes your step 3 and 4. Basically, the only thing remaining is actually to go to your assets folder and to create a config folder here and to store an environment file here. Inside the environment file, we'll actually be storing our public access token. So when we use a Mapbox, we'll actually be needing that public access token to render the map tiles. So that is why I'll be storing there, and for the purpose we're using the .env package. So one thing that is good is I have already included all the packages that we're going to use in here. So once you actually run the project, you do a flutter pub get, you should be good to go. You don't have to manually install or look for packages. So that would be all about setting up the project. I would highly recommend that you also move to the documentation and have a look at how or what other steps they are suggesting you to do. I have included the links to the documentation in the description. Why I'm saying is because I have added a lot of things like permissions and other stuff inside the Gradle files, inside the property list files, which is actually helping the application run even with these small configurations. But it's good that you know the complete set of changes that you have to make to include Mapbox in any project. So that being said, let's start and run our application. So we can run the application by clicking on the run main.dart button here, and that actually will launch the main.dart on my simulator, which is this. And for the very first time that you actually install the application, it's gonna take you, let's say, a minute or so. It depends on your system, but that should be what the typical time should be. So it will first run an Xcode build. It will also do a pod install, and then after completion, it will actually show up on my screen. So now the Xcode build has been done, and you see that my application has also launched on the simulator. I should actually shortly be greeted by my splash screen, which I have here in the UI folder. And yeah, so here we have our splash screen. And also we see our application. So it's good that our application is up and running. So all the configurations we did, all the keys we have put them correctly, and things have started to work. Let me just quickly go through two things. So I'll tell you what all folders and files we have and what the application is looking like corresponding to those files, and then I'll also talk about what our aim is before we get started towards coding and fulfilling that aim. So the first thing is going through the folders. So we have a constant folder here that has a restaurants.dart. This is a list of maps, so it's pretty similar to a response you might get from an API, let's say. And here we have an ID, a name, items, and image, and the coordinates corresponding to each restaurant. And then we have the helpers folder. So helpers folder contains some of the helper functions. So we have some commons where we have a function to get latitude longitude from restaurant data. We have do exceptions, which actually deal with the exceptions raised by the do package, which you'll be using to send API requests. Then we have the directions handler. So directions handler are sort of manipulating the directions API response and storing them in the shared preferences. And then we have a shared preference.dart, which contains functions to set and get information from the shared preferences. So we are going to use shared preference quite a lot. So we have actually declared them here in the before the main function. So we can globally use this variable shared preferences throughout the application. Then we have the request folder, as the name suggests. You guessed it correctly. It is here that we use our do package and we make a request to the direction API. We'll talk about this in a bit. Obviously, we'll come to this. But the response that we get from here is actually plays a crucial role in designing those routes that we are going to do in this project. Then we have our screens. So inside screens, we have these three screens. We have a home management, we have a restaurants, we have a restaurants table. So in our case, the home management actually is the entire screen that you're seeing, which contains this bottom navigation bar and the app bar. And the other two screens are whatever content you're seeing in between. So the restaurant maps is something which we'll work on and we'll build. The restaurant table already contains a visual representation of the restaurants. We have all those restaurants in the form of cards. And we also see the distance here, which we will be modifying based on the data that we get from our directions API. After that, we have already seen our splash screen. So splash screen right now just redirects us to the home management screen after a particular duration. And I have put it in this way because we will be using the navigator thing in the end in the same way as it is now. And we'll be adding some asynchronous calls here, some function calls, which will actually make this entire function asynchronous as well. So we'll come to that in the very next step. And the other thing that we have is widgets. So widgets, we have the carousel card .dart. So this is something which we'll use to generate a list of all the restaurants, which will stack on the top of our map, and then we'll actually be moving those carousel list. We'll be using that carousel list to focus on a particular route, that is to say, to connect our current location to a particular destination. So that would be all. Let's actually get started with writing the first few lines of code. Alright, so the first thing that we have to do here is actually show the user current location or the current location of this device in this restaurant's map page instead of the let's build something awesome line. For that purpose, I'll be declaring three variables here. So the first one will be called location, and I'll call the constructor. I have to import this package, remember. So that is done. The second one will actually be a boolean. I'll call it service enabled, and the third one will be permission status. So since I'm not initializing them right away, I have to add those question marks which show that these variables can be null. But yeah, that's just taking into account the Flutter's latest convention of null safety. So the service enabled variable will store a boolean that will check if the service has been enabled or not. Since we are going to use the await keyword, we have to make this function asynchronous. And that we do that by calling location dot or dot service enabled. Now, since it's a boolean, it's possible that it has the value false. So in that particular case, we'll just go ahead and instead of saying service enabled, we will say request service. All right. Now similarly for the permission status, I'll check if the permission has been granted or not. You can do that by writing await location dot has permission, which returns a boolean, and then you also check if the permission has been granted or not. So in this case, since it's not a boolean anymore, we have to actually check it with permission status dot denied, and here we'll say permission granted equals await location dot request permission, not runtime, request permission. Okay, so now the permissions and the service enable thing has been handled. The next thing that we have to do is to capture the location data of the user. So again, you guessed it right, we're going to store it inside a location data variable, and I'll also call this location data for convenience. And what it will have is await location dot get location. Yeah, that's the function. And now since we already have the location data, I want to store it in a latitude longitude format. So I'll call this latitude longitude. I'll name the variable current latitude longitude, and I'll store latitude longitude, and where here the latitude will actually be location data dot latitude, and I have to make sure that it's not null. Similarly, location data dot longitude, and also making sure it's not null. So we have the current latitude and longitude stored. Now what we have to do next is actually call the shared preferences that we had defined in the main.dart file here, and though that shared preferences will store the latitude and longitude. So we'll do that by using the set double function. Set double function is used to save a double value to the persistent storage, and I'll name the key location and I'll name the key latitude and longitude, not location, latitude and longitude, and the latitude will of course store location data dot latitude, and I'll just copy the line again, I'm lazy, and I'll call it location longitude in this case, longitude and longitude. Again, make sure that these are not null, and now we have stored them in the shared preferences. The last thing is to remove the future delayed. We don't need it anymore because we already have some asynchronous function calls here. So that would actually complete the task for my splash screen. If I go ahead and restart the application, so right now it fetches the user location for me. I have already granted the permission of this application since I ran it once before, but if you're running it for the first time, you must get a warning from the Apple system that whether you want to grant location or not. Now the main.dart file has the shared preferences, so we can access this in any file. I'll go to restaurant's map, and under the MapBox related variables, I will create a variable that can basically access the data from shared preferences. So again, its type will be latitude longitude, since we just want to reduce our work, and I'll call latitude longitude. and I'll use a helper function this time that will be get latitude longitude from shared preferences. So if you go to shared preferences dot you see this function, and it does nothing but just to get those two doubles in a latitude longitude format. Now inside restaurants map, I have already initialized this. So in the text field, what I'll do is instead of this, I'll create two template strings and separate them by comma. The first one will contain, of course, you need to remove the constant here because it's no longer a constant now. And inside here, you have to say latitude longitude dot latitude and latitude longitude dot longitude. So once that is done, we see that we have the current user latitude and longitude, and this device is right now in Apple Park. I have set it to this, and in fact all the restaurants around here that we have in this file are also located within a few 100 meters or 400-500 meters of this location, so that we can show the routes properly. So if you are using a different device or a custom location, make sure to set it to something similar or something within the Apple Park that you can use directly. And follow along with the video. So next thing that we can do is to use the MapBox package and render a map on the screen and show our current user location. Okay, so to render the current location with a MapBox, we'll need two variables. One is like a MapBox controller, and the other one will be actually a camera position. So we'll declare both of them as late. Now late is a term which is related to null safety, which just says you that your variable will not be initialized when it is declared. So I'll call this initial camera position, and I'll call the other one as just controller. So it will be MapBox controller, and this is just controller. So inside the init state, what we have to do is actually we have to initialize the initial camera position. Initial camera position will actually be camera position, and inside the constructor what we'll do is we'll add a target. So the target will be the same latitude longitude we had defined previously in line 14 here, and the other thing will be a zoom. So I'll prefer a zoom of 15 for this. So zoom basically determines how much area of the map you are seeing. Now that initial camera position is done here, we have to go to this function on map created, which I've already written for you. So we'll need all these three functions. So I have some comments here so that you can also understand what's happening. But on map created is a function that will be called when the map is created, and on style loaded will be called when all the map styles are loaded. So we'll be using both of them. But for now, what I can say is inside this function, I'll say this dot controller is equal to controller. So it will assign the controller that is from given by the MapBox widget, and I'll set it to the one that I have declared here so that I can use it globally inside this particular class, restaurants map state. So now inside safe area, we'll remove whatever we have, and we'll put let's say, what should we put here? So we'll put a stack. Now why I'm putting a stack is because I later have to stack those carousel cards on the top of my map. So I'll just start with the stack, and the next important thing is to use a size box. That is because the MapBox widget that you're going to use, that needs to have a predefined size or a predefined height to it. Otherwise it will just expand and you'll get error. So I'm going to use media query for this. I'll just set it to 0.8 times of the height of the screen. So that is done in this way. I'll say size.height and I'll set it into 0.8. Okay, so the child of this will be our MapBox widget. So for us it is MapBox map. That's the widget you have to use. And the MapBox map will need a few things. Now the first thing will be access token. Remember I told you before we'll be using the .env because that is where our environment variables have been stored. Now MapBox map-ish, okay, we'll see what's the issue here. So we'll need the initial camera position, okay, and the .env also needs to be imported. Yeah, so we have imported the .env as well, and the environment variable that we'll need for our case is actually called MapBox access token. And the initial camera position, yes, you guessed it right. We have already declared it, so we'll set it to initial camera position. After that, what we have to do is to set a few more properties. So on map created, again we have a function over there on map created, and then we have on style loaded callback. We'll also set this to on style loaded callback. Although this function is currently empty, but still that's okay. And we need my location enabled, which is a boolean, and by default this is actually false, so we have to set it to true so that I can show the user his or her current location. And then we have the my location tracking mode, which you can set to my location tracking mode dot GPS tracking. And then you have a min max zoom preference. So I set a min max zoom preference so that the user cannot just zoom out infinitely and see the entire globe. We don't want that, but we want to keep him within a particular zoom level. So I'll set it something within 14 to 17, and my by default one is 15 that we had defined here in the initial camera position zoom. Okay, so that is done. One more thing I'll add here is like below this stack, or maybe I'll just add it separately. So that is a floating action button. So a floating action button, we'll have to add it to the scaffold, and that floating action button will be giving me the ability to migrate to my current user location. So how are we going to do that? Again, I think it needs the on pressed argument by default. And inside the on pressed argument, we'll write controller, and this is the MapBox controller we defined above, and we'll write controller dot animate camera, and this requires a camera update variable. So we'll say camera update update dot new camera position. So the new camera position will hold the initial camera position. So the aim of this particular thing is to bring me back to my initial location if I tend to migrate or go somewhere away. And what else we need to add? Okay, we'll add a child, of course, and the child in this case can be just an icon. So I'll make it constant since it's a constant thing, and we'll say icons dot my location. Okay, so now if I do a hot restart, I see that my map tiles are being rendered, and the map tiles are being rendered now, and I see my current user location as we had predicted. It is near the Apple campus, and now we have our latitude and longitude shown on the map. So let's go ahead and play around a little bit and add the carousels on the top, and also have a look at how the direction API works. Okay, before we continue writing more code and understanding how to write those carousels and stack those on the top of our map, let's have a look at the MapBox playground that we have for the directions API. So you can find this in the link to the description. I'll add the link to this website as well. And what we have here is we have a access token, which is my public key. We can add coordinates, we can add the routing profile, we can add the format in which I want the response to be in, and then also configure a few more options. So what we'll quickly do is I'll paste the coordinates that I want in this format: longitude, comma latitude, and semicolon longitude, comma latitude for even up to 25 waypoints. So the first one represents my current location in the Apple Park, and the second one represents the location of one of the restaurants. So what I want to do next is I want to set the routing profile to cycling, because I'm assuming that we are cycling, and then we also want to set this overview to full, and now I can go ahead and click on add coordinates. So I see a beautiful animation. It goes from New York to California. And here I see my current location. If you remember, we saw this on the map, and this is connecting me to one of the restaurants out there. And one interesting thing to note is that we have multiple routes to that. So by default, the one that is shown is the one that has a shorter time, 1 minute 28 seconds as compared to 1 minute 34 seconds. And yeah, so that is how the directions API work, and the response that we'll receive is actually something interesting which we can have a look at. If I click on show more here, Okay, so we have routes, and you have two routes since there were two possible options. Remember, here we had two possible options, and within each route, I have a geometry and I have some coordinates. Now, these set of coordinates that I have here, these are actually latitude longitude pairs, or to be more accurate, longitude latitude pairs, which is the way that data is returned from Mapbox. But this geometry object is something which we will need to actually plot those routes in our application. So this is one thing that we are interested in. The other thing is to take a note of the duration and the distance. Now distance is in meters, duration is in seconds. We'll be using both of them to actually also decide that how far the restaurant is from my current location, or how much time it will take for me if I were to follow the shortest possible route. So that being said, we can now go ahead and have a look at how to implement this in our Flutter application. So the first thing we'll have a look at is the Mapbox request file here. So this is the file I had actually shown you earlier, and we were using the do package here to make a request. So the request that we are making is actually following the format that we saw here in the request URL, and this format here has your the pairs that you have put in, that is the coordinates, and also some more configuration variables that we have set, like overview and routing profile and other parameters. So that is what we are taking care of in our code as well. And we are creating a URL based on that, and then we are sending the request to the directions API. The response data that we'll be getting will be similar to what we saw in the website, but we're interested in only three things. So what do we do is we make use of a helper function, a directions handler. I had also talked about this. This actually modifies the response, and it gives me those three things: geometry, duration, and distance. And then I create a map of those, and I call it modified response. And then what I do is I actually save it to my shared preferences. Now these are the two functions, and now we have to actually call the Mapbox request, and then make use of these functions here and save it to shared preference. So where should we do that? We will go to our splash.dart. So inside splash.dart, just before this, you see this comment that says get and store the directions API response with shared preference. So for that, what we'll do is we'll do it for every restaurant that we have. So I'll run a loop. I'll say int I equal to 0, I less than restaurants dot length. Did I make a mistake? No. Okay. Yeah, so restaurants dot length, and then I plus plus, and what I'll do is I'll say map modified response, that is, I'll set it equal to await get direction API response. So this is the one that we have in our Mapbox request file, and this requires a current latitude longitude, which is already set to the current latitude longitude we had defined before, and then we have an index here, so I'll just set it to I. And then what we can do is we will call the other function, that is save direction API response. We'll use the index as I again, but this time we will have to encode this response in the format of a JSON string. Now that is because the shared preferences cannot store maps and other complicated variables, but they can only store double strings, integers, and such stuff. So we'll actually encode this. So for that, we'll write JSON this one dot encode, and it expects an object. So that for me will be my modified response. So those two lines will fetch the response from the directions API using the do package, and it will save it to our shared preference. So now I'll go ahead and restart my application. And one interesting thing we can note here is actually if we open our run, we see that all these four entries, so the 4 times we called our the directions API, we get correspondingly two prints. So those two prints are actually correspond to the distance and the duration for that particular restaurant. Once that is done, now we have the data with us, the duration and the distance data. So just for an example, let's go to the restaurants table which we have, and we had this hard coded 2 kilometers everywhere. So inside restaurants table, let's go ahead and actually use our proper distance now. So what I will do is I will again use a template string. I'll let the kilometers stay. I'll remove the constant, that's something which is important. And the template string, what it will do is it will make use of another helper function, and that is called get distance from shared preferences. This gives an index, and that index is also specified by my list view builder, and I divide that response by 1000 since I want to have it in the form of kilometers instead of meters, which is returned by the API, and I want to convert this into string, and I want to fix the number of decimal digits to 2. So if I run this now, I see that these things change instantly. We have 0.40 kilometers, 0.25 kilometers, 0.80 kilometers, and 0.42 kilometers. So from prediction, at least if I ignore the route, it looks like maybe KFC is the one will reach the fastest to. So now the next step is to render those cards of these restaurants as a carousel slider on the top of this map. So we can slide and have a look at which one comes first. In order to add those carousel items, we'll have to define a few variables. So the first thing we'll define is a list of maps, and that I will call as carousel data. And what next I can do is to define a integer, that is page index. So this will represent the current carousel item that is being focused on. And then we'll define another widget, I mean a list of widgets. So I'll mark it as late because I won't initialize it yet while I'm declaring it, and I'll call this as carousel items. So what we will do now is we'll also sort these items that we are going to show on the screen in order of their duration. So it means the restaurants which I'll reach fast, that will be shown in the first position, and then the second, and so on. So for that I'll have to write a loop here. I'll call it as integer index equals 0 and index less than, again you guessed it, it's restaurants dot length. Okay, I think something happened. Restaurants dot length. And inside the loop what I will have is actually two variables. So I'll call the norm distance, and I'll set it from the helper function, that is get distance from shared preference, and the index is shared, and I'll divide it by 1000 to store the value in kilometers. And similarly what I can do is I'll get the num duration, I'll declare that, and I'll get duration from shared preference. Now both of these were saved in another helper function, if you remember, and we are now fetching them. The last thing is actually in putting data into carousel data. So I'll call carousel data dot add. I'll make a map of 3 items of 3 keys. So the first one is index, that will store the index. The second one is distance, so that stores my distance, and the third one is duration, which will store my duration. So now that it's already added, what we can do is we can go ahead and sort this. So I'll call carousel data dot sort, and now this is how we sort a list of maps in Flutter. We'll take 2 map objects and we'll compare them. So I'll compare a of duration with b of duration. So I'll see if the a of duration is less than b of duration, and if that's so, then I will actually give it a 0, otherwise I'll give it a 1. Okay, so now my data is sorted inside the carousel data, and then I'll generate a list of the carousel widgets. So you remember this late variable late that we declared here. So the carousel items will now get in data, and they will be of the format of list widget. So I will mention that, and then I will use dot generate function. Now we know that the length of this is actually restaurants dot length. And for each index, what we'll do is we will take carousel card. Okay. So for each index, what we'll do is we will take carousel card, and so carousel card is something we have defined before in the widgets. So I'll call this carousel card, and that expects the index which is already given, but we want to replace that index with the index of carousel data. So that is because once we have sorted this, so we want the data, the indices here to be the indices that is corresponding to the sorted indices. So that I don't give the index of the first restaurant, but I give the index of the restaurant with the shortest time. So that is why I'm using this. And the next thing that I will do is for distance. So for distance, similarly, I will give the distance of the same thing, but now this will just say distance. And again, for duration also we will do the same thing. Okay, so that being done, our list of items of carousel items is generated. Now what we have to do next is actually we will go to our widget, so the build widget that we have here, and we'll use a package that we have called or that we have used in the application, and that is called carousel slider. So for the carousel slider, I'll just declare it below this one, so below my sized box, and that carousel slider will take a few things. Now the items here can be carousel items, and then the options will have the type carousel options, and inside carousel options we'll define a few parameters now. Okay, so the carousel options will take a height, let's say 100, and then we'll take a viewport fraction. I'll say it is 0.6. So viewport fraction represents how much of the current widget you are having a looking at, and how much of the next widget or the next page you can see. And then we have initial page. I'll set it to 0. Then we have enable infinite scroll, which is true by default, but we don't want that. We'll set that to false, and the scroll direction obviously needs to be axis.horizontal, and we need a function on page changed. So on page changed will actually take a function of this type that takes an index, and it has a carousel page change reason. So that's the type, and we call it reason. So this, okay, reason, sorry, yeah. And now inside that we'll call a set state, and we'll set our page index to the index represented by this. So what does this function do? It just changes the page index. So we can make use of page index to keep a track of what page we are on, and the index will just show me what page I am on when I traverse through that carousel slider by moving it. So that would be all. If I just restart my application on this particular page, on the very first page, I should now be seeing a set of widgets that I have. So these are the carousel cards, and I had guessed it right that KFC is the shortest path and the shortest time. So that is the carousel that is coming in first. And then we have Pizza Hut, and then we have Starbucks, and then we have Domino's. So the next thing that we have to do is actually to show these restaurants on the map, and to join them by polylines or by line layers. So we'll do that using the controller that we have already declared. So for that, what we can do is, first of all, we'll have to declare a list of camera positions. So again, I'll mark it as late. I'll call it late list camera position, and I'll call this as k restaurants list. And then what I'll do is, inside this init state function, we'll go ahead and add, basically initialize the map symbols. So what we'll do here is we'll say k restaurants list, that is equal to list of camera positions, and will then generate it. So this is similar to how what we did in the previous case to generate the list of carousel widgets. So here also we will have a length. So that length will actually be the same that we used here, which will be restaurants.length. Again for the function here, so we will return a camera position, and that camera position will set the target to get latitude, longitude from restaurant data. So this is another helper function, and that is just getting the latitude and longitude corresponding to a restaurant, and the index that we will give here is actually carousel data of index. That is again because we want to specify the proper index and not the index in the order in which we are generating it. So that being done, we will need one more thing here, that is a zoom parameter. So zoom parameter I will set it to 15 and I will complete this. Now the next thing that we have to do is in the add source and line layer, we will add these sources to the map, and we'll add a few lines to the map. So by line here I mean polylines, which are basically routes connecting the current user location to one of these restaurants that come on the map. So the first thing is to add the animate camera, like so that if I see a particular route, I should focus on that particular restaurant, and I'll do that by saying controller dot animate camera, and here I'll use camera update. So you remember this is something we did for the current location in our floating action button as well. So I'll say new camera position, and I'll say k restaurants list of index. And for the next thing, we need to add a polyline between source and destination. So for that, what we'll do is we'll take the geometry. You remember geometry we got from the response of that directions API, and we'll call another helper function that gets us get this geometry from us from the shared preferences, and we'll call it as carousel data of index and of index. And then what we'll do is we will create a final fills object which will help us render this on the map. So this has a peculiar way in which we have to write it. So the first thing will be called feature collection, and then the next thing will be actually features. So inside features, that expects us to give a basically a list now. And in features, what we'll do is we will provide a object, and in that object our type will be a feature. So since it's a feature collection, the type is feature, and we provide ID. So ID is 0. So let's assume we wanted multiple features to be rendered, so even catering things like a polygon in the map or something like that. So that's why we have IDs and stuff. But if we add properties, in properties we will need to add the type of data that we want here, but we don't have any property here though, so I'll just leave it blank. And the last thing is geometry. So geometry is what we got from here, and that is geometry. Okay, so my fills is ready. Now the other thing is to remove line layer and source if it exists. So since we'll be traversing between these cards basically, so we will be generating polylines on the map for one card, and for the next card we'll be generating another polyline. So we need to remove those polylines before we actually generate the next polyline. Otherwise it will be just too many polylines on the map, and we want to show it one at a time. So for that, what we'll do is we'll check if remove layer is equal to true. So remove layer is something we don't have yet, but we'll set that in a bit. And here, if it's actually equal to true, what we'll do is we'll say controller dot remove layer, and that remove layer will take a ID of lines, and this is what we will create here. And again for this one, we will actually remove the source then, and the source that will remove is fills. So remember that you should always do this in this particular order. You cannot remove a source when a layer exists, because the layer depends on that particular source and it will give you an error. So make sure to maintain the order in line 73 and 74. After that, what we can do is we'll just add these things. So I'll say await controller dot add source, and add source will take fills as the source ID, and the property that we'll have here is GeoJSON properties, and here the data that will be equal to fills. Sorry, not minus fills but fills. Okay, so the source is added. The next thing is adding a layer. So we'll say await controller dot add line layer, and since we want a line on the screen, we don't want any other kind of layer, so that's a function we'll use. And instead of source ID, I will use fills now. Instead of layer ID, you see we remove that layer here, so that's the layer that we'll use, that is lines. And in properties, we'll use line layer properties. So line layer properties have a few things we have to add, that is line color. So line color, I prefer to use the color that we had seen on the demo in the playground, the directions API. So I'll call it colors.green, and I will convert into hex string RGB. Now remember, you have to do this because line color will expect so line color, if you see this, it expects it dynamic, but it expects the color in this particular format. So make sure to convert that into a RGB string, I mean a hex string. And then you can have a line cap. So line cap can be round. That means your line edges and other things will be round. And similarly line join. So if there are two lines joining, that also you can set it as round. That gives a nice curvature. And then we have the line width. So I'll just keep it as 2 on the map. And now we have actually added the source and the line layers. So the very last thing that we have to do is to put this here. So inside on style loaded callback, we have to actually go for all the camera positions inside the list of camera positions for restaurant that we made. So I'll call it as krestaurant in krestaurant list. And for each restaurant, what I'll do is I will await my controller, and I will add a symbol. So I'll do add symbol here, and that add symbol will take some options. So the type of this is symbol options, and the symbol options here, they will need some parameters now. So the parameters are geometry. The geometry will be krestaurant.target. So that is the latitude, longitude. And we need the icon size. So icon size I'll set it as 0.2, and I have already put something for you in the assets. So that is the icon image, and the icon image will have a path of assets /icon /food.png. Okay, so that does it for us. Let's use a double quoted string because I kind of like it. Okay, that's there. And the last thing we have to do is to call the add source line layer, and we have an index and we have a remove layer. So on style loaded callback is the first time the styles are loaded, and that is when I want to show the line and the symbol corresponding to KFC. So my index here will be 0, and the remove layer that I will do is false. Since I don't want to remove anything the first time I am rendering a layer, but when I want to actually render the next layers, I want to remove those things. So when should I call that? I will call that inside the on page changed function. So in the on page change function below the set state, go ahead and call the function add source line layer, and the index can be the index you have specified, and this one should be true because now you want that to be removed. Now once this is done, I can go ahead and restart my application. It seems we have some error in restaurant maps. Let's fix that quickly. Or have a double comma. Okay, so now if I go ahead and hot restart, my application will restart again, and in the run you can see we are getting these distances, and bam, you have your current location connected to KFC. So you see these 4 things that we have on the map, right? So we have these 4 restaurants on the map. Again, this is why I made this one to get back. So we have the 4 restaurants here, and the KFC is the one it's connected to. If I move on to the next one, that is Pizza Hut, it connects me to Pizza Hut. If I go to Starbucks, it connects me to Starbucks. And if I go to Domino's, it connects me to Domino's. So that is the aim that we wanted to actually achieve, that whenever you go to a particular restaurant, we should see the path to that. You can also zoom in and have a look at the proper path. Again, I'm sorry for getting away. But if you zoom in, you can see the path here, and that is how we have achieved the aim of our project. So that would be all for this one now. One more thing we can do is to actually have a look at the Android emulator. So if you open the Android emulator and look, and you have put a, let's say you put a slightly different location here, and then this list of restaurants that we see here might change because the distances between them will be different. So I hope that video gave you a complete insight of how you can use Mapbox in your web and mobile applications. And for people who are starting with their map projects for the first time in a Flutter application, I really hope that you found it interesting. One more thing which you could do is actually implementing a turn-by-turn navigation. So let's say you have your Uber application and you're actually in a car going to a destination. So all those turns and things that you have, the entire route can be simulated. That is something which you can also implement using Mapbox, and it will be a pretty interesting session to build a project like that. So if you want to, if you want me to go ahead and do that, then let me know in the comments. For today, thanks for watching the video. Make sure to like, share, and subscribe. That really keeps me motivated. And I'll see you in the next one.